Good evening, everyone. Today I'll be presenting one of the most straightforward sorting algorithms in computer science, which is insertion sort. We'll focus specially on how this algorithm processes input and processes output step by step. Insertion sort. Insertion sort is a simple comparison based sorting algorithm that builds the final sorted array or list one element at a time. It is similar to the way people often sort playing cards in their hands. It builds a sorted array by taking one element at a time and inserting it into correct position among the already sorted elements. In insertion sort compares backward from the current position, shifts larger elements until it finds the correct place. After n number of iterations, the first n elements are sorted. Insertion sort is a simple sorting algorithm that works by iteratively building a sorted sublist. It picks an element from the unsorted portion of the list and insert it into its correct position within the already sorted sublist. This process repeats until the entire list is sorted. Now, what is insertion sort? Insertion sort is a simple sorting technique that builds the final sorted array one element at a time. It works the way we sort playing cards. For example, how we input and output. Let's define what we mean by input and output in this context. The input is an unsorted array or a list of elements. The output is the same array in non-decreasing order. Now we have to see that how insertion sort works. Insertion first point, start with the second element, assuming the first element is already sorted. Now compare with the element before it. Third, shift larger elements one position to the right. Fourth, insert the current element into the current position. Last, repeat for all elements in the array. Now, advantages of insertion sort. There are three advantages: simple to implement, efficient for small or nearby sorted data sets, stable sort, does not change the relative order or equal elements. Now we have only one disadvantage: not suitable for larger data sets due to O(n) squared time complexity. Now let us study the algorithm of insertion sort. In this indicates that the algorithm named insertion sort, and it takes an input array and indices ranging from 0 to n minus 1. Sorts a given array by insertion sort. This is a comment explaining that the purpose of algorithm to sort an array using the insertion sort technique. Now we have to input an array. This comment clarifies that the input A of n orderable elements. Now next, output. This tells us that the output is the same array but sorted in non-decreasing order. Each element is less than or equal to the next. Now let us come to the algorithm for I to 1 to n minus 1 do. this is the main loop of the algorithm. It starts from the second element and goes to the end of the array. The reason we start from the 1 is that single element array is trivial sorted. Now v to a of I, we store the current element into the temporary variable v. This is the element we are going to insert to the current position sorted part of the array. Next, j n I to 1, I minus 1, we initialize a pointer j to the index before I, the last element of the sorted subarray. Now let's go to the condition in which j is this loop shifts element in the sorted subarray that are greater than v to the right, and it continues as long as j is within the bound the a of j greater than v, the current element is greater than the one to be sorted. Next, a j plus 1 to aj. This shifts the larger element a of j one position right to a of j plus 1. Next, we have j I minus 1. We move to the pointer j one step to the left. The next element is sorted portion. Last, a of j plus 1 to v. Once we find the right position, we insert v at the location j plus 1. A of j plus 1 is the location where v is inserted. This is the algorithm of insertion sort. Now iteration of insertion sort. Before insertion, a of 0 to a of j is sorted. A of v is the current element to be inserted. Elements from a of j plus 1 to a of I minus 1 have been shifted to right. Then a of I to a of n minus 1 is the part of the array yet to be sorted. Direction of insertion sort is that a of I is inserted in its proper position among the preceding elements previously sorted. Now a of I is inserted in its proper position amongst the preceding elements previously sorted. We could get a question that what are the main differences between bubble sort and insertion sort. Bubble sort is a comparison based bubble sort is a comparison based sorting algorithm where we swap adjacent elements if they are not in the order. Insertion sort is constructs the final sorted list by moving one element at a time. We have an example to solve. We have an input array. Let us solve sort this in ascending order using insertion sort. So we'll do by step execution. Step 1, I is equal to 1 and key is 12. Second element in this. Compare with 45 and 12. 12 is less than 45. We'll shift 45. We'll insert 12 at position 0. Now next the array will be 12, 45, 78, 34, 23, 89, 10, 67. Now step 2, I is equal to 2 and key is 78, which is at second index. 78 is less than 45, so no shift. The array will be 12, 45, 78, 34, 23, 89, 10, 67. Step 3 will be I is equal to 3 and key is at 34. Okay, 34. Compare with 78. Shift 78. Compare with 45. Shift 45. We have to shift 34 previous to 78 to 45, then 34, 12, insert 34 after 12. The array will be 12, 34, 45, 78, 23, 89, 10, 67. Now let us go to index 4, where step 4 will go to index 4, key is 23. Compare with 78, 45, 34. Shift all. 23 is less than all three of this, so we have to shift to the left. 23 is greater than 12, so insert after 12. Though the sorted array will be 12, 23, 34, 45, 78, 89, 10, 67. Now step 5, I'll write this. Okay, 12, 23, 34, 45, 78, 89, 10, 67. So next I is 5, then key is 89. 89 is greater than 78. 89 is greater than 78, so no shift. Step 6, index is 6, key is 10, shift 89, 78, 45, 34, 23, 12. Insert 10 at position 0. So it is less than all the numbers we have in an array. So 10 comes in the 0th position. Now array will be 10, 12, 23, 34, 45, 78, 89, 67. Now step 7, I is equal to 7, key is last element 67, shift will shift 67. 67 is greater than 10. Here we'll do 67 is less than 89 and less than 78, so we'll shift two positions, 89, 78. 67 is greater than 45, so it will be inserted after 45. Insert after 45. Now the final sorted array is 10, 12, 23, 34, 45, 67, 78, 89. Time and space complexity of insertion sort, we have best case, sorted input, ON, average case, worst case, space complexity, O1, become it sorts the array in place. When to use insertion sort? Insertion sort is ideal for small data sets, nearly sorted arrays. When stability is important, equal elements maintain order. Now I'll conclude. To conclude, insertion sort is not the most efficient for large data sets, but it's an excellent algorithm to understand the core ideas of sorting, especially when analyzing how inputs turns into output through step-by-step logic. Thank you.